Okay, so welcome to this session on Java 8. Thanks for having me tonight. It's really great to be here. And despite the sun outside, I mean, there are a lot of people in the room, so it's really nice. So tonight I will give you an overview of Java 8. So the agenda, well, it's basically a preview of what Java 8 will be about. We have to keep in mind that it's really early days of Java 8, so we have started to work on Java 8. When I say we, it's really different experts that are involved in the different GCP expert groups. So we have a good idea of the things that will be part of Java 8, but since we are in the early days, a lot of things can change. At the end, I will also tell you some way to help us, because you can help us to shape what Java 8 will be. So it's really a best guess on or an educated guess on what Java 8 will be. Now, if you have already seen a presentation from someone from Oracle, this is the mandatory slides that basically say that everything which I will say about the futures can change. So roadmap, API, and so on can change. And basically, if you try to understand the slide, it also says that you shouldn't make any purchase decision based on what I will say, because everything can change. Having said that, there is no Java 8 product today, so there is nothing to buy. So it's pretty easy to follow that advice. So just keep that in mind. Roadmap and so on can change. So the current release of Java EE is Java 7. Java 7 was finalized in 2013, so nearly 2 years ago. We did quite a few things in Java 7. So HTML5 was a big theme for Java 7, so we have introduced a new WebSocket API. So it gives us the ability to have a full duplex bidirectional communications in the Java EE platform. We have introduced a JSON API, so it's a standard way to deal with JSON. We have enhanced some of the existing API to be able to cope with HTML5 applications. The servlet API has been, for example, enhanced with asynchronous non-blocking I/O. The REST API, we have a new REST client API in the platform, and so on. So HTML5 was the big theme of the platform. Something else in Java 7, developer productivity. It's not something new. I mean, the idea is to try to make the platform more easy to develop with, so that you, the developer, has to do less. That's something that has been started with Java 5. So in Java 5, we have started to introduce annotation, to use convention over configuration, and so on, just to try to simplify your developer life. We have continued that in Java 6. In Java 7, we have continued to try to simplify as much as we can the platform. Finally, Java EE is an enterprise platform, so we have to make sure that we do provide the right capabilities for enterprise application. In Java 7, we have introduced a new batch API to develop and run batch jobs on top of the platform, and so on. So Java 7, the current release, was finalized nearly 2 years ago. So at that time, we had to start about the futures, so Java EE.next, Java EE 8. So obviously we are looking at the market. I mean, there are some obvious trends that are coming and that we are observing on the market. HTML5, that's something which is important, reactive programming, security, HTTP2, and so on. So out of those topics, obviously there are things we would like to do in Java EE. We also have a lot of source about things that we need to do in the platform. Obviously we have discussion with the different Java EE licenses, so Red Hat, IBM, and so on. We also have discussion with the different experts involved in the GCP. There are also issues that are filled against the different JIRA of the different specification of Java EE. When we do conference, I mean when we visit jugs, when we go to DevOps and so on, when you talk to us, that's also something that we take back and we discuss internally, and so on. So we have a lot of source about things that we need to do in the platform. So we have a lot of good ideas that we would like to have in Java EE 8. Now, the thing is that when you have good ideas, sometimes a good idea to challenge those good ideas with a larger community. And also, if we would like to do everything that we had on our wish list for Java 8, we won't have Java 8 for the next 5-6 years, which is too far away. So what we did beginning of last year, we did a survey. So we reached out to the community and we basically put in that survey so really our wish list for Java 8. And we have asked the community, okay, Should we do that in Java 8? If so, what form should it take? If not, why? And so on. And we also had a few open questions. So people had the ability to suggest things that maybe we didn't add in our wish list. This is the end result. I will not go into details about that slide. If you want to learn more, just go on glassfish.org/survey. But at least the outcome of that survey gives us a starting point about the thing that we should start to work for Java 8. We have to keep in mind that everything is done through the GCP, so it's just a starting point to kickstart really the different GCP EGs. What's important is, for example, the first one is JSON-B. So it seems obvious that we need to do JSON-B in the platform. If you take the second most wanted features, which is security simplification, 11%. If you add it to the first one, security interceptors, it seems that if you combine those two together, security is really a big deal. So that's something that we need to think of for Java 8, and so on. So what I will do tonight, so we took that and we started really to work on Java 8. So this is basically what I will present tonight. So this is really, as of today, the state of Java 8. Keep in mind, everything can still change. So we took those various features and we tried to combine them together to have some team for Java 8. So the early team, I mean the team of, as of today, of Java 8, HTML5 web tier enhancements. That's something that we have started in EE7. And if we look at the market, when it comes to web user interface technology, they are all being replaced in favor of HTML5. So we have to make sure that Java EE, the platform, is able to deliver those HTML5 applications as well, because at the end of the day, it's a server-side platform. So HTML5 is really something which is key for the platform. The second team is of development. Again, it's not really new. That's something which we have started in EE5. And we would like to continue to simplify the platform. And finally, infrastructure for running in the cloud. So those are, as of today, the three teams for Java 8. So what I will do in the next 15, 60 minutes, I will give you an overview of the different things that we would like to do for those three teams. Clearly, there is one team for which we have made more progress. This is the first one. So when I will give details about some of the APIs and so on, clearly as of today, as of now, I have more details on that team than on the other one. So the first one, HTML5 web tier enhancement. So we plan to do different things on that front. We plan to introduce a JSON-B binding API. We plan to enhance the JSON-P API, which has been introduced in Java 7. We would like to add a SSE to the platform. We will introduce a new action-based MVC framework. And finally, we would like to add HTTP2 to the platform. So let's look at the first one, JSON-B. So in the survey, we had this question. So that one was specifically about JSON-B. And nearly 80% of the of the people who answered said that yes, we should do JSON-B. So, I mean, it's obvious. So in Java 7, we have a JSON-P API, so a JSON processing, but when it comes to binding JSON to Java object, we don't have that. So if you want to do that, you have to use a proprietary solution. Obviously, it's not really the ideal solution. So we would like to address that. So we will introduce a JSON-B API in the platform. So what is JSON-B? It's an API that allows you to marshal Java object to JSON document and unmarshal JSON document to Java object. You should see that API to JSON. Sorry. On the XML side, we have JSD, so unmarshaling Java to and from XML. We would like to have the same API, but for JSON. So the API will provide default behavior. The thing is that if you look at the JSON object type, it's very basic. I mean, we have strings, we have numbers, Boolean, object, array, and I think that's it. On the other side, we have the Java object type, which is obviously way richer than that. So the API will provide default behavior, and you will have the ability to override that default behavior. Now, if we look at the market of JSON-B provider, it's already a very crowded and mature market. I mean, we have Jackson, JSON, Moxie, and so on. You name it. There are more than 10 solutions today on the market. So The idea of that API is not to reinvent the wheel. The idea of that API is to provide a standard API that will give you the ability to plug a JSON-B provider. And it will then be up to the different JSON-B provider to provide the capability that will that will justify the fact that you will use that solution versus another one. It could be performance, it could be extra capabilities, and so on. So again, JSON-B, it's really a standard API in which you can plug an existing JSON-B provider. So how it might look like. So I have a Pojo, which is a person. I'm using the at entity, so it's a GP entity. I create an instance of that person. It's Duke, and so on. So how it might look like. So first, I need to have an instance of a marshaller. So for that, I will use a JSON context, create marshaller, and then I will have the ability to configure that marshaller if I want to. In this case, I want to have some pre-printing. Then once I have my marshaller, well, I can just pass it my Java object, so Duke, using the marshal method. And what I will get in return will be a JSON document that I can use. Obviously, through the JSON context, you will have the ability to specify which JSON-B provider you would like to use. In this case, I don't specify any JSON-B provider, so I will have the default one. Then once I have my marshaller, I just need to pass my JSON object, and I invoke the marshal method, and in this case, I'm using a writer. So this is my Java object, and it will be written down to that mascot.json document. So I would have something like that. And again, this is the default behavior. So for example, you see that the name key here, but well, it's just inferred based on that guy here. But let's say that I want to have that in French. So the API will give you the ability to override that default behavior. So you will have specific annotation to specify which key you want to have there, for example. And once we will have JSON-B in the platform, we will be able to do really JSON end-to-end. So on the client side, we will get JSON. JAX-RS will use JSON to an unmarshaled JSON document to Java object, and from there, obviously, we'll use just the rest of the platform. So it will add a nice extra capability to the platform. And obviously, that's something which is very important when it comes to HTML5 application. Being able to easily consume JSON is something which is key in that space. In that space, another API that we would like to enhance is JSON-P. So JSON-P has been added to Java EE 7, so it was a new Java EE 7 API. And in JSON-P 1.1, we would like to do different things. We would like to adopt some of the new standards in the JSON space. We would like to add support for AC8 and so on. So let's look at some of those. So the first standard that we would like to introduce in the API is JSON pointer. So as the name implies, a JSON pointer is basically a syntax that allows you to reference a value within a specific JSON document. So this is an example. So /phone. So it's the first object in my JSON document. Then I want to go to the phone key and then the mobile key. So let's look at an example. So we have a JSON array. So it's a JSON object. So this is the JSON representation. So in there we have two users, Duke and Jane. So we define a pointer, so /0/name. So it's an array. So /0 is basically the first object in that array, and then name, that's the key here. So we are talking about Dukes. Then obviously we want to do something. So we are here. In that case, we can do a get value, for example. So we would get in return that value here. So we can do a get value, but we can also do some JSON operations. So add, replace, and remove. This is an example how it would work. So again, we set the pointer. So it's a new JSON pointer, /0/name. Then on that pointer, we invoke the replace method. We specify which JSON object, which JSON document we are talking to. And then we just create a new value. So we will basically replace Duke, the name Duke, with Alex. Now, something that we have to keep in mind, the JSON API deal with immutable object. So what we will get in return here is a new JSON array. So we won't touch the original JSON array. We will get a new one. So JSON pointer is one of the standards we would like to add to the API. Another one that we would like to do is JSON patch. So what is a patch? Well, a JSON patch is a JSON document that describes a set of operations that needs to be applied to another JSON document. So this is an example. So as I said, JSON patch is a JSON document. So this is a JSON document. So it's a JSON array. There are two operations in that one. The first operation is a replace, and the second one is a remove. Each operation is performed in sequence. So we do the first one, then we do the second one. If one operation fails, the complete patch is aborted. In terms of operation, we have had replace, remove, move, copy, and test. So the idea is that we will take that patch, we will apply that patch to another JSON document to transform that JSON document. So this is an example. So we have the patch on the left side, and we have the target JSON document on the right side. So the first operation is a replace. So we are using a JSON pointer to specify what we would like to replace. So /0, so the first object, phones, mobile. So we would like to replace that mobile phone. So we perform the operation that works. We can move on to the second operation, which is a remove. So in that case, it's a remove, and we would like to remove object 1. So basically that object. So this would be the end result. On the Java side, it would look something like that. So we have two JSON documents. We have the the target document, and we have the patch itself. The two are JSON documents. So first we define a JSON patch. So new JSON patch, we specify the JSON document that we would like to be used as the patch. And then we just need to apply that patch to the target JSON document. That's what we do here. And again, this is an immutable API, so what we get in return is a new JSON array. So we don't touch the original array. We will also likely have this API, which is based on a builder pattern. So it allows you to easily build your JSON patch, basically. So that's what we do here. So new JSON patch builder. Then we have this builder pattern where we just invoke the different methods calls to construct the patch. So we would like to, the first operation is a add, the second operation is a remove, and at the end we apply the patch to a specific JSON document. And what we get is again a new JSON object. It's an array in this case. Another standard that we would like to do is a JSON merge patch. And I have to say that around that one, so I've just discovered that one last week, and I'm still puzzled about the real use of that one. So because sometimes when you use the JSON merge patch, you can get some weird results. So I will not spend too much time on this one. So, but the idea is the follow. So you have an original document, you have a merge patch here, and basically, so that one says that, for example, the title needs to be replaced. So the original title needs to be replaced by hello. When you have a null, it basically means that you want to get rid of that key value. So the family name, though, since we have a null here, it should be removed here, and so on. So again, this one is to me fairly new, so I'm not yet sure how it will work. The thing is that for those two, so for the JSON patch and the JSON merge patch, we will have an API that you can use to transform a document. So you will basically apply the patch, but we will also have a method that you can use to do a diff between two documents. That's what we do here. So for example, JSON patch diff. So instead of applying the patch to the original document to get the target, what you do, you just do a diff between the original JSON document and the target document, and what you get in return is a diff. So it's basically a JSON patch that describes the difference between the two documents. Something else that we would like to do in JSON P11. So something I need to mention is that Java 8 will be based on Java SE 8 at minimum. So the minimum version that you will have to use is SE 8. So in JSON P, we would like to have something like that. So that's basically a use of the stream and the Lambda API of SE 8. So we have an array of cars. Let's see. So we do a filter on the brand, and we only take the HODI, and then we take the serial number, and what we get. So we basically get the list of HODIs that we have in our set of cars. But there is a fundamental issue in that samples. If you look at the return time that we have here, we have a list of strings. Basically means that from there we are outside of the JSON P world. And why? Because the JDK collectors can only return list and maps. So what we would like to do in JSON P11, we would like to introduce specific JSON collectors. That's what we do here. So we have a specific JSON collectors, and that's exactly the same example. The only fundamental difference is that the returns type of that method here is a JSON array. So we are still in the JSON world, so we can continue to use the JSON P API, which is obviously something which is important. So something else that the JSON P EG would like to do, and they have just started that discussion, it's JSON Big Data. So the idea is very simple. Well, it's very simple to explain, but not really to implement. Let's imagine that you have a services that is using Facebook. So you do a call on Facebook and you get a huge JSON document in return. When I say huge, it could be, let's say, 1 gigabyte JSON document. Obviously, you don't necessarily want to have to deal with the whole document. I mean, we would like to give in the API the ability to deal with subset of very large JSON document. So that's what JSON Big Data is about. And clearly, they have just started that discussion. So as of today, I have no idea how it will work exactly. So this is basically what the JSON P EG would like to do. So if we move on the web front, something else which was quite high in the survey is SSE, server-side event. So what are SSE? Well, it's part of the HTML5 standard, so it basically gives the ability to do server-side push once over HTTP. So the idea is very simple. So we have an HTTP client, a browser, for example, that do a connection to a backend. The connection is established. So the backend, so the server, has a channel to send notification in a synchronous way to the client at any time. This is something which is widely used on the internet. So there is a specific media type, text event stream, and so on. So the only requirement is that it's always the client who needs to start the connection. But once the connection is there, the server has a channel to push notification to that client. So we would like to do SSE in the platform. I mean, it's widely used. It's part of HTML5. So if you take any HTML5 browser, it supports SSE and so on. Now we have this question, where should we do in the platform SSE? Where should we standardize that? It could be in the Servlet API. It could be in the WebSocket API, because at the end of the day, WebSocket is also about giving the server a mean to push payload to the client. The only difference is that WebSocket is bidirectional and full duplex. SSE is just server to client. We could do that in JAX-RS, or we could have a specific API, a specific GSR just for that. So a lot of discussion, and at the end of the day, it was decided to do that in JAX-RS. There are various reasons why SSE makes sense in JAX-RS. First, SSE, if you look at the use case, it's often used with RESTful web services. So it's one reason why it might make sense to do SSE in JAX-RS. It also happened that Jersey, which is a JAX-RS reference implementation, already supports SSE. So we know what it takes to add SSE support to JAX-RS. And it turned out that it's not very difficult to do. So at the end of the day, it was decided to do SSE in JAX-RS. So it will look like that. So this is basically a JAX-RS endpoint. So we have the add path annotation, add get, add produce. The produce type is specific to SSE, obviously. Then we have this new type of object, event output. And here you also see that we are starting a thread. It's probably not something that you would do in using that approach in a Java EE application. But the idea here is just to illustrate the fact that we need to send event in an asynchronous way. So basically the event would be sent in that external thread. And that thread would look like that. So we have this event output object that we are using. So we invoke the send method on that event output object, and then we just put it some payload. So basically, whenever I do that, that payload will be sent to the connected client. On the client side, this is JAX-RS client, the JAX-RS client API. So it's very similar to what you are doing today. So we define a web target. So this is my JAX-RS endpoint on the network. We set an event source on that web target, and we define this callback on event. And basically, this callback will be invoked whenever the server is pushing through SSE some payload. So we do here what we need to do with the incoming payload. What we should not forget to do is event source open. So that's basically where all the heavy lifting is done. So that's the establishment of the connection. That's the registration of the callback and so on. So for us Java developers, it's fairly easy to do. It's fairly transparent. This is Java code using the JAX-RS client API, but obviously you can use an SSE JavaScript client API that you have in any HTML5 browser. You can use that against, well, you will be able to use that against an E8 SSE endpoints. So SSE will be part of JAX-RS 2.1 in Java E8. So something else on the web front that we would like to do is MVC. So we had this question, should Java EE provide support for MVC alongside GSF? Now, to be honest with you, the question could have been phrased in a different way, because obviously GSF is MVC based. So, but anyway, we had some clarification. So when we are talking in this question about MVC, it's really about action-based MVC versus GSF, which is component-based MVC. Nevertheless, 60% of the person said yes, it might be a good idea to do action-based MVC in the platform. So we would like to introduce a new MVC framework in the platform. And when I say MVC, it's really an action-based MVC framework. Why? Well, that's the result. That's something that is coming from the result. But also, that's a question that we get, well, that's a remark we often get about Java EE. I mean, in Java EE, we have GSF. GSF is widely used, but there are people that don't want to use GSF. So we just want to provide choice. So clearly this is not about replacing GSF. I mean GSF, there will be an update of GSF in Java E8. The idea of that new GSR is to provide a different way of doing user interface in Java EE. So you will have the choice. And at the end of the day, you might use another solution. So Angular or something like that. So just about providing choice. So the idea of that action-based MVC framework is to glue together the different technology we already have in the platform. So we would like to avoid as much as we can to reinvent the wheel. So before trying to reinvent something to solve a need, we would like to see if we don't already have a solution in the platform. So the model will be based obviously on CDI. We would like to have validation on the model, so obviously we will use bin validation. The specification doesn't talk about persistence, but clearly if you want to do persistence, GPA might be a good solution. It's already in the platform. For the view, so the view, it's really how you will render the user interface. So what your user will interact with is basically the templating capabilities. So for the view, there are different solutions. So the platform, so Java EE already supports Facelet and GSP. So we think that it's a good idea to provide those as default view technology. I mean, they are already there, so why not provide them? Having said that, we also think that people might want to use something else. So we would like to provide, again, a choice. So we'll have an SPI that will allow you to plug external templating solution in that MVC framework. Then for the controller, we had this question: should we invent something new, or should we try to leverage something? A lot of discussion, and at the end of the day, it was decided to base the controller part of the MVC framework on JAX-RS. So this is how a controller would look like. So this is basically a JAX-RS resource method. So we have the add path annotation that we have borrowed from JAX-RS. We have the add get annotation, again coming from JAX-RS. So the only thing which is new, we have those two new annotations, add controller and add view. So this, what we are doing here, so we are defining a controller class, because the add controller annotation is put at the class level. And we have, in this case, one controller method, this hello method. We're specifying that in this case, whenever the user is hitting that method, the view that needs to be rendered is that one, view1.xhtml. So in this case, it's a facelet view. Another example, so this is basically the same example. The only difference is that the add controller annotation is now at the method level. So only this guy is a controller method. We are not using the add view annotation in this case. So how we specify the view, we just need to return a reference to the view. So that's what we are doing in this case. So in this case, whenever someone is hitting that hello controller method, the view a.gsp need to be rendered. For the model, we are using CDI, so nothing new there. So it's pure CDI code that is coming straight from Java 7, Java 6 in fact. Now for the model, we are using CDI, but there is also an alternative which is based basically on a hash map that allows us to support non-CDI templating engine. For the view, as I said, out of the box we do support facelet and GSP. So this is a facelet. In this case, we are using expression language, which is part of the platform, to basically bind the view to the model. So we would like to use the greeting message from the model through CDI in this case. This is a GSP view, again using EL. This is a free marker based view. So out of the box, we do support GSP and facelet, but we have this extension mechanism that allows you to support a different type of templating engine. So right now we show, we give the extension for free marker, I think it's on my slide, yeah, free marker, velocity, time leaf, mustache, handlebars, people, and I think there is another one. So this is mandated by the specification. We give you the extension to do that on top of Ozark. Ozark is the reference implementation for that MVC GSR. So right now that GSR is in early draft, so you can already check the specification. You can already play with the specification. We have milestone 1 of that specification, so you can play with that as of now. So something else on the web front is Servlet 4. So in Servlet 4, we would like to introduce HTTP2 support. Very quickly, HTTP2 is trying to solve the issue we are facing with HTTP 1.1. So today, most of us are using HTTP 1.1. HTTP 1.1 was finalized in '99, so it's a fairly old protocol that we are all using from the morning to the evening. There are a lot of issues with HTTP 1.1, and the basic, the fundamental reason that explains all of those issues is the fact that HTTP is based on TCP. TCP has been designed for long-lived connection, and HTTP is basically about having a short connection, so a lot of short connections. So you do a lot of small requests, and so clearly there is a mismatch between those two protocols. So there are different solutions to try to work around that mismatch. Another issue that we have with HTTP is head-of-line blocking. So the spec says that the request should be delivered in the order they have been requested. So I ask resource 1, resource 2, resource 3. I get resource 1, but for some reasons resource 2 is blocking, so that means that I won't get resource 3 until I don't get resource 2. So a lot of solutions to work around those issues, but clearly those are not really solutions, they are more workaround. So HTTP is really trying to solve all of that. On my slide, I still say HTTP is nearly done standardization. This is not true anymore because as of 10 days ago, HTTP2 is finalized. There are two RFC for HTTP2, 7540, the first one, HTTP2, and then there is HPAC, which deals with header compression, 7541. So HTTP2 is about reducing latency, address the header flag blocking, having a true parallelism in the protocol. Right now in HTTP 1.1, if we want to have some pseudo-parallelism, we need to open multiple TCP sockets, which is very expensive. But the nice thing about HTTP2 is that HTTP2 preserves the semantics of HTTP 1.1. So we still have the notion of gets, of HTTP headers, and so on. So the fundamental difference between HTTP2 and HTTP 1.1, HTTP 1.1 is a text-based protocol, HTTP2 is a binary-based protocol. And the fact that we have this binary-based protocol gives the ability to do a lot of things, a lot of optimization. In HTTP2, everything happens over one single TCP connection, so no need to open multiple TCP connections. Over one single TCP connection, we can have multiple streams. So a stream is basically an interaction, a channel between the client and the server, and we can have multiple streams at the same time. This is due to the fact that we have a binary protocol and that the streams are split in frames. So each stream is split in frames, and we can interweave frames for different streams at the same time. So that means that we can multiplex streams. The protocol also supports priority. So we have multiple streams. We can define weight, priority on the different streams. Server push, I will explain what it is, and header compression. So the fact that it's a binary-based protocol gives us a lot of ability to do nice things. So this is an example of an HTTP 1.1 request. So this is a post, and this is the payload, just a JSON object. In HTTP2, we would have two frames in a stream. So the first frame would be a header frames. So this is a binary frames. And the second frames would be a data frame that contain the actual payload. But for you developer, you don't really see that. You still have the notion of post, and you have your payload. Since we have this notion of frames, we can interweave in the two directions the streams. So it's really multiplex streams that we can have between the client and the server. And one of the use cases of that is a server push. So server push works like that. So we have the client which send a request to the server. So it sends a header frames, and the clients want to have an index.html. So the client is asking index.html to the server. So the server knows that to render that particular page, the client will also need a style sheet and a JavaScript file. So the server can decide proactively to send those two files, even though the client has not yet asked to get the style sheet and the JavaScript file. So for that, the server will send specific frames. It's called server push promise to push the style sheet and the JavaScript file. So the server basically tells the client, okay, you have asked the index.html file, but I would like to push in your cache that style sheet and that JavaScript file, because I know that you will need them very soon. The client can decide to refuse them. I mean, if they are already in the cache, the client will just cancel those streams. So it basically will cancel the fact that it will say, no, I don't want them. And obviously, at some point in time, the server will also push the actual file which has been requested in the first place. So the HTML file. So this is HTTP2 server push. So it's really about giving the ability to the server to pre-populate the cache of the client. So it doesn't replace WebSocket or SSE. For example, as of today, there is no JavaScript API on the client side for that. So the only thing that we can do, we can push stuff in the cache of the client. But obviously, if we combine that with SSE, we can also, so we can push stuff in the cache, and we can send an SSE notification to tell the client to do something with that payload in the cache. Something else which is part of HTTP2 is HPAC, header compression. And it's based on a very simple observation. If you look at HTTP requests, well, you will see that most of the time we are just sending again and again the same HTTP headers. So this is the first request. So I want to get a pictures / resource on that example.com site. So this would be the HTTP2 header stream corresponding to that request. This is my second request. The only thing which has changed is really that guy here, so the path. So I just want a different picture on that same host. So the two peer, so the client and the server, will basically maintain some sort of tables with the HTTP headers. And what will be exchanged over time is just a diff of that. So the second request, we know that all those guys are implicit because they haven't changed. So that would be the new header streams for that second pictures. And obviously, when it comes to dealing with cookies and so on in HTTP headers, if we have that kind of mechanism over time, that should really improve the flow. Again, from a developer point of view, it's part of the network, it's part of the protocol, so you don't necessarily, well, you will not see that. It's fully hidden. So, big features of HTTP2, request response multiplexing, stream prioritization, server push, binary framing, upgrade from HTTP 1.1. So this is done over, so in HTTP 1.1 there is a specific upgrade mechanism that is used, for example, to upgrade an HTTP connection to a WebSocket connection. We can use the same approach to upgrade an HTTP 1.1 connection to an HTTP 2 connection. So those are really the main features of HTTP 2. But if you look at the developers, from a developer point of view, we think that most of them will be hidden. So the only one that we would like to expose through the Servlet 4 API, stream prioritization, so having the ability to see which priority has been set on stream, and also change the priority on the streams, server push, and upgrade from HTTP 1.1. And clearly, this one is the big deal of web development. So this is an example of how we would use that in JSF. Again, you have to keep in mind that any web application know what resources are needed on the client side. So we will have this kind of method on the HTTP request, is push request, that we can use to basically push in the client cache any resources. And it's really the only thing that will be exposed. So we need to know which resources we would like to push, and then everything will happen at the network layer. And the rest will be fully transparent for us, developers. So that was an overview of what we plan to do on the web tier front. I haven't talked about GSF. There will be a GSF update. JAX-RS, I've just mentioned SSE, but we will likely have other features in JAX-RS 2.1 and so on. Now moving on to the ease of development team. So that one is a little bit difficult to explain because basically ease of development is something that is done through the platform. I mean, all the API need to think how they can simplify their use. Having said that, there are some obvious candidates. For example, CDI alignment. I mean, JAX-RS and GSF could be more closely aligned with CDI. So that's one of the things we would like to do in Java EE 8. WebSocket scope. As of today, so in Java EE 7 we have introduced WebSocket support, but we don't really have the notion of WebSocket scope. Maybe that's something that we would like to do. That's something I would like to see, but at this stage we don't know if we will do that, and so on. So let's look at some of those. So the first one that we would like to do is around the GMS API. So in Java EE 7 we have done a complete revamp of this GMS specification. So we went from 1.2 to GMS 2, and it was really a huge revamp of the specification. We have simplified the spec a lot. The only thing which we haven't really touched in that revision of the specification is MDB, message-driven bin. So basically the AGB that you use with GMS. So what we would like to do, we would like to introduce a new alternative to MDB. This is an MDB today. So I have my MDB class that implements that listener. Then I have my callback. I use the @message driven annotation to specify to the Java EE application server that this is an MDB. I use the activation spec to basically configure my GMS resource adapter. So I set my queue and so on. And here I have my callback that will be invoked whenever there is some payload coming on that GMS queue. So you see that it's a fairly old-style programming. So we would like to have something which is a bit more appealing to use. So maybe we should go to a model like that. So we have a simple POJO. We introduce a new annotation at GMS listener. If we don't specify anything, convention over configuration, so we would have the default queue that would be used. In this case, I'm specifying which queue we need. And then we have this callback. So basically, by putting this annotation on this callback, that callback will be invoked whenever there is some payload coming on that queue. So that's one of the things we are looking at to simplify in Java E8, specifically for GMS2. Something else. So when it comes to simplification, clearly one of the key technology that we have used through the years to simplify the platform, CDI, context and dependency injection. I mean, CDI is really becoming the key technology that is used across the Java platform. So in CDI, moving from 1.2 to 2.0, the CDI expert group has a lot of ideas that they would like to tackle. Let's look at some of them. So the first one, they would like to be more modular. So if you look at CDI today, CDI, that's obviously context and dependency injection, but there are more than that in CDI. For example, we have event capabilities. So the fact that as of today we already have a lot of CDI and the EG would like to add yet more capability gives, well, for some use case, CDI is becoming too big to be adopted. And clearly this is outside of the Java EE world. So the CDI EG would like to boost adoption outside of Java EE, so they would like to basically be more modular. So they have this idea of splitting the specification in sub-specification that would be called parts. Last time I checked, they are thinking to have two parts, an SE part, and based on that SE part, an EE part. That would basically be the whole CDI. And clearly, being more modular will help the adoption of CDI outside of Java EE. Something else that they are looking at is how should we bootstrap a CDI container. I mean, in Java EE, this is all handled by the Java EE container, but in Java EC, all the implementation have their own way of bootstrapping themselves. So they would like to standardize that. And again, this is to boost and increase the adoption of CDI outside of the platform. Something else that they would like to do in CDI 2 is asynchronous events. So events is something that we have in CDI since the beginning. Since CDI 1.0, we have synchronous event capabilities. So it's basically an implementation of the observer pattern. So it works like that. So we have, in our application, we have a message producer. So we inject an event of some type, some event. Then at some point in time, we invoke the fire method on the some event. And we obviously have the ability to attach some payload to it. So we just basically raise an event. And somewhere else in the application, we will have one or more observers. How should we specify that this is an observer? We just need to use the @observer annotation. So this guy will observe the some event method. So whenever that guy is firing an event, that guy will be invoked. But this is fully synchronous. And we have more. I mean, we have qualifiers if we want to do some more fine-grained control of the event type and so on. We can have more than one observer and so on. So this is not something new. I mean, we have that since the beginning. What they would like to do in CDI2 is add synchronous capabilities. So it would look like that. So we will have a new event. So fire async. To fire an event in an asynchronous way. What we would get in return is a Java EC8 completion stage, so we can see what is happening over time. We would have the ability to pass it some executor services, so it will give us some controls on how those events will be handled, and so on. Something else that they would like to do this is obviously only for synchronous event. They would like to add the notion of event ordering. So right now in CDI, if you have multiple observers of the same event, they will all be invoked, but the specification doesn't mention in which order. Now, using that add priority annotation, we can specify that. Now, the add priority annotation is maybe, it's a bit misleading because clearly it's more an order than a priority. I mean, add priority 1 will be invoked before add priority 10. So the lower your priority is, the higher you will be invoked in the chain. So that's something that should be part of CDI 2. And there are more stuff that they would like to do in CDI 2. Something else is pruning. So simplification is also about removing old stuff. So that's something that we do in a gentle way. So we have a clear, well-defined process that basically say, okay, we are thinking about removing that non-use technology in the platform, but we do that in multiple steps so that it doesn't happen overnight. So pruning is something that we'll continue to do to basically get rid of the old stuff that are still part of the platform. The last theme, infrastructure for running in the cloud. So 2 new GSR in that front. The first one, Java E management. So it's a new GSR that deals with how we can easily manage a Java E container. And the second one is a very broad GSR, Java E security. So the first one, Java E management 2.0, is basically a complete revamp of GSR 77. So we have this GSR 77, which is a very old GSR. It's still called G2E management. That basically deal with how we can manage objects within a container. So we would like to borrow some of the idea of that and revamp those notions. Not only that, we would like also to put it a REST front end. So that basically means that you will have the ability to manage in a standard way through REST any Java E 8 containers. And since REST in Java EE will have SSC, we can also think about having the ability to send notification from the Java E container to any management application through REST/SSE. So this one, the Java E management, they have just started. So at this stage, we don't have a good idea on how the API will look like. So that is something which we'll have to follow. Another GSR, Java E security 1.0, so GSR 375. They have different ideas that they would like to tackle in that GSR. One of them is to have CDI-based interceptors. So in Java E7, we have introduced CDI interceptors that allows you to define transaction boundaries outside of EGB, so in any CDI managed beans. In Java E8, we would like to have the same idea, so having CDI interceptors, but to deal with security concerns. And not only that, we would also like to give you the ability to use the business context of the application. So an example is this. So a transfer fund and method is annotated with is authorized. So basically, to transfer a fund, I need to be a manager, so I need to be in that role, and I can only do that during office hour. Another example is this method, get salary. So to get the salary of an employee, I need to be in the role manager, but also that employee has to be one of my direct reports. So as a manager, I cannot see the salary of others employee. And we are also thinking about having the ability to externalize those roles in some sort of external repository. Something else that will be part of the GSR is user management. As of today in Java E, there is no easy way and no standard way to manage users. I mean, adding a users, create a users, and so on. So what we would like to do is to introduce some user source definition that will define a user's store. It could be a LDAP, it could be a database, and so on. It doesn't really matter. Then we would have a user services and a user info API that we can use on that user source definition to manage users. So to get users, to change users, to add users, and so on. So this is an example. So this is my user store, LDAP user store, and I'm using the API in this case to gather users and specific attribute of that users. Something else that we would like to do is password alias. So the idea is that is the following. So sometimes in your code you have to store password in clear. I mean to connect to the LDAP, to connect to the database. So you have to store that either in the code, in deployment descriptor, and so on. So clearly you have to do that, but it's not something that is recommended. So with that in place, we would have the ability to basically define an alias. So that's something that you will store in clear in your code. And next to that, we would have a secure store with the actual password. And basically, the alias says where in the store we can get the password. So this is basically what password alias is. And this is a feature which will be very useful when it comes to cloud deployment. Because you will basically bundle your password in a secure way along with your application. And so GSR 375, they have just started, but I've talked about user management, but they will also like to tackle the role mapping issue that we have today. I've mentioned the authorization interceptor, but clearly this is it's just the beginning of that GSR, but they have a lot of things to do, but they are very active. I mean, that expert group is hard to follow because they are cranking so many mails a week that it's very hard to follow those discussions. So very quickly, I gave you an overview of Java 8 as of today. So the 3-team HTML5 Web2 enhancement, ease of development, infrastructure for running in the cloud. So that's basically the new Java management API and the security GSR. So something that we have to keep in mind is that whenever we update an API in the platform, we would like to make sure that it uses Delabassee 8. I mean, Delabassee 8 is the minimum version of Java 8. So it's up to the different AG updating their API, but clearly Delabassee 8 is something that they have to keep in mind whenever it comes to updating any API. So where we are today, so far we have 11 GSR, so that means an expert group that has been started and actively working. Now some of them are more active than the others. For example, that one, the MVC, they are in early draft. CDI is also very active. JSON P11 is very active. Security is very active. That one, not so active at this stage, but things should change in the near futures. So 11 today, but we might expect to see more. Again, this is purely speculative from my side. But for example, JCache, maybe it's a good idea to have it in the platform now. If we look at the batch GSR, there are some improvements that would be welcome in that GSR. I've mentioned in the WebSocket scope, maybe that's something that needs to be tackled, and so on. GPA, I likely see a revision of GPA. So over time, you should expect to see more GSR that will pop up. In terms of roadmap, again, remember the first slide. So the final release of the specification Q3 2016. But you shouldn't trust roadmap, so we'll see. Nevertheless, contribute. You can help us with Java 8. Before that, obviously Glassfish, the Java reference implementation, open source. So whenever Java 8 will be finalized, we will have a Glassfish version to support that. Open source. So nothing has changed on that front. So how you can help us? Well, you can help us in being involved in the GCP. So you can join an expert group. So I mean, if you have, for example, something, if you have skills around HTTP2, you might want to join the Servlet 4 expert group, and so on. Having said that, joining a G is a lot of work. So if you don't have the time to spend on the G, we have another program which is called Adopted GSR. Adopted GSR is basically where we ask Jug to take a GSR and adopt it. Adopt it, we mean you take a GSR, You try to understand it, you write samples, you try to break it, you provide us feedback because we still have time to fix things. So maybe there are obvious things that we have missed, we don't know. So that's clearly where you can bring a lot of value, adopted GSR. So pick any GSR, I mean JSON B, JSON P11 and so on, and help us to promote it and to push it towards the community. And please, if you have feedback, provide us that feedback. If you want to learn more about what is happening in that space, Java on the server, follow the Aquarium. That's a blog that we try to maintain with the colleagues, where we push news around Java EE. And I mean, it's just not, it's not an Oracle blogs. I mean, we obviously talk about Glassfish, WebLogic, but we also talk about Wildfly and so on, the others, Java implementation when it makes sense. That's not Spanish, right? Oh, shit. I've changed. Last week I gave the presentation in Barcelona, and I've put so gracias in Spanish, right? Yeah, okay. I've put gracias there,